Hello and welcome to Huawei Artificial Intelligence Overview MOOC. In this course, we'll capture a bird's-eye view of artificial intelligence technology and its ever-growing applications in various industries and in telecom sector. We'll also try our best to understand the basic concepts of machine learning and deep learning. I'm Dr. Kishore Biswas, the IT Training Director Engineer from Huawei Global Training Center, and I'll be your trainer for this course. Let's get started. Welcome to Chapter 1 of our AI MOOC. In this chapter, we'll explore AI big picture and AI applications. Our objectives in Chapter 1 are to understand the big picture of AI and be familiar with the latest AI applications. Moreover, to understand the relationship between AI and emerging technologies. So, let's jump in. Let me start by asking you a question. Which of the following images on the screen do you think best represents artificial intelligence? We have the good old if-else program, a big data center, many intelligent applications, the mysterious deep neural network, and finally, the super robot, the Terminator, that we see in many sci-fi movies. Which image would you choose as the best representative of AI? Please think about it. Well, there is no wrong answer here. This is because the definition and capabilities of AI have kept changing throughout its development. Let us briefly explore this development background. The history of AI can be traced back to the late 1950s and early 1960s. The term artificial intelligence was introduced by John McCarthy, Marvin Minsky, and Nathan Rochester in 1956. There have been many ups and downs in AI research over the past decades. We usually divide these development phases into three eras: the narrow AI or weak AI era, the general AI or strong AI era, and the super AI era. Weak AI can only perform its assigned tasks based on rules and decision-making processes. In this era, we have been able to get machines to simulate the human reasoning process. We have developed expert systems such as Deep Blue, IBM Watson, etc. And we can train learning algorithms with big data. On the other hand, in the strong AI era, machines are expected to learn by themselves using AutoML and similar techniques, and will be able to understand complex concepts such as human language and cultural implications. Finally, super AI would likely be creative and surpass the human mind, as seen in many sci-fi movies. Nevertheless, that day is still a long way off. Right now, we are at the intersection of the weak and strong AI era. Although current AI systems are limited in capabilities, they are still very useful in many application scenarios. Some of AI's most important capabilities today are machines' ability to recognize text, audio, video, graphics, signals, learn patterns and internal relationships from large datasets, and predict various trends and probabilities. Today's AI is mainly big data based and learning oriented. We will explore the concept of learning from datasets later in this course. Artificial intelligence has been a buzzword for some time. But how would we define artificial intelligence? And why is it so important? There are several definitions of artificial intelligence. However, one of the easiest to understand is that AI is a field of computer science that deals with creating intelligent machines that work and react like humans. For better understanding, we can think of AI as a tree with many traditional disciplines, their theories, and techniques at the root of the tree, on top of which are various applications. In short, AI is a mixture of many disciplines that gives us many applications or tools to solve our problems better. The field of AI could be further divided into these main sub-disciplines, such as machine learning, computer vision, natural language processing, robotics, expert systems, etc. Nonetheless, today we use various AI applications in our daily lives. Now, let me ask you another question. What AI application have you used today? Any that comes to mind? Let us take a look at the most commonly used AI applications today. Examples: facial recognition, virtual games, VR applications, voice to text and text to voice, machine pets, smart promotion, recommendation systems, medical image recognition, weather forecasting, and space exploration, and many others. Have you noticed a pattern here? What capabilities do these applications have in common? Do they have recognition, learning, or prediction capabilities? Let's take virtual games as an example. To play such an indoor virtual game, for instance, beach volleyball, we need to stand in front of a game screen connected to multiple cameras and AI applications installed locally or in the cloud. The AI application can recognize our gestures, our game movements, etc. through the camera. This is the recognition capability in play. Then, while we mimic our moves in volleyball, our opponent, the computer, play its move based on the preset rules of the volleyball game. But the more we play, the more data is collected by the camera for analysis by AI algorithms. Over time, the algorithm is trained with more and more data and gradually learns about our playing habits, strengths, and weaknesses. Finally, the AI can predict what our next move in the game might be and can play accordingly. This is why, in most modern computer games, the more we play against the computer, the harder it becomes to win. Have you noticed this phenomenon? If not, try it next time. Anyway, all other applications also have the capabilities of recognition, learning, and prediction. Let us now look at some other latest AI applications. We will list them here and discuss some of the applications in detail in our future course. We have famous search engines, Google virtual assistants, like Hold for Me and Google Duplex, various AI writing assistants, many natural language processing tools, AI graphics editors, AI alarms for emergencies, and AI media feeds. We use various AI navigation tools, biometric recognition apps, deep learning platforms, decision management tools, and virtual household agents. That is not all. We have more. We may have heard of or even used AI financial platforms. We use many smart apps, smart security tools, and smart keyboards. We use smart speakers, smart mailboxes, smart car systems, and the latest black magic, deep fake. Deep fake technology challenges the old adage, seeing is believing. If you are interested in deepfake, you could do a little research. Then we have autonomous cars or robo-taxis in the early stages. Vaccine development with AI. AI optimized hardware, and exciting AI plus quantum computing. These are the well-known AI applications of today. Do you know most of them? Let us now discuss the relationship between AI and some other emerging technologies, such as big data, cloud computing, IoT, and 5G. Let us start with the relationship between AI and big data. The world's internet users, all mobile device users, machines, servers, labs, sensors, various devices, satellites, etc., are generating a huge amount of data, or big data, every second. We can process this enormous amount of big data and mine valuable information, knowledge, and insights. All kinds of AI services need this knowledge or insight. But how would you define data? Is data the same as information? Is data something that can only be stored in database systems? Well, data is an abstract expression of real-life phenomena. Therefore, to solve our real-life problems with machines, we need to feed a huge amount of selected data to the machine or algorithms for processing. Our goal is to move from extracted raw data to information, knowledge, or insights. To gain insights or extract knowledge or information, we need to apply various processes such as classification, association, mining, etc. Wisdom, on the other hand, is something that today's AI algorithms cannot yet achieve. Let us now focus on the diagram on the right. This circle represents the domain of AI, which includes many subdomains already mentioned in the AI tree. Remember? However, machine learning is the core of AI that enables AI to be intelligent. And deep learning is a subset of machine learning. Both machine learning and deep learning rely on a huge amount of data. In other words, big data to learn from. If we think of AI metaphorically as a vehicle, then we can compare big data to the fuel or energy of the vehicle. Therefore, we can say that big data empowers AI. Do you understand this better now? If so, let us think about another question. Is it possible to express almost everything in the world through data? Please give this a serious thought. Research and industry in artificial intelligence, big data, cloud computing, IoT, and 5G are advancing steadily. The relationship between these technologies is characterized by the synergistic effect on each of them. For example, big data and AI can improve the performance and efficiency of cloud computing and 5G, which in turn supports the implementation of AI. We can compare today's big data to last century's oil, AI to a car engine, and IoT devices to a nodding donkey. We need to keep in mind that AI is supposed to solve our problems, automate our work processes, and help us with repetitive manual tasks. Once our AI applications gain these capabilities, we need to deploy them on a broader platform, such as a cloud platform, so that more people can conveniently access these AI capabilities or services anytime, anywhere. Since the cloud platform is a virtual distributed space, we need a good connectivity mechanism to connect devices. And 5G plays a crucial role in this advanced connectivity. IoT devices could be thought of as the sensory organs of the human body that can collect and send data. Just like with our eyes, ears, nose, etc., we gather information from our surroundings. Our brain could be viewed as a kind of AI system. The information we collect through our sensory organs is sent to our brain through our nervous system. 5G connections work like these nervous systems. Finally, AI models are trained with this data, just as our brains process data and derive the results as common sense or wisdom. Anyway, big data, artificial intelligence, cloud computing, IoT, and 5G are the new infrastructure of the future digital world. Well. It's time for our first quick quiz. Who is excited about this? I know, I am. Anyway, our first question is, which of the following concepts could be used to describe artificial intelligence best? Is AI algorithm? Is AI machine learning? A cross-disciplinary field? Or is AI all about creating robots? Easy one, right? Our next question is, where does machine learning model learn from? From deep learning? From bots and robots? The cloud? Or data? Please pause this video now. Think about these two quizzes and try them yourself first. Well, the answer to the first question is C, as we discussed when we defined AI with a tree. Machine learning is not AI. It's a part of AI. There are many machine learning and deep learning algorithms used in AI. Therefore, AI is not just any algorithm. Moreover, robots are some products of the AI implementation. AI is definitely not about creating robots only. The answer to the second question is D. We train our models with data. In other words, machine learning models learn from data. I hope you have got your answers correct. Finally, let's recap what we have learned in Chapter 1. Artificial intelligence could be thought of as a box of tools or applications that we can use to make our life, work, and various procedures automatic or even autonomous. AI is an interdisciplinary field of computer science. Currently, machine learning and deep learning are the core research directions of AI. Current AI capabilities are mainly recognition, prediction, and learning. The next trend of AI is understanding complex concepts like human languages, emotions, or even cultural backgrounds. We are at the end of Chapter 1. I hope you have enjoyed the lecture. I'll see you in Chapter 2.